Seventh graders, let's go through lesson 4-9 on writing scientific notation. What is scientific notation used for? Where do you see scientific notation?
On a calculator to keep a whole times 10.
Okay, why would they put the number in scientific notation rather than just showing the number on a calculator?
Because there's not enough space.
Right. There's not enough space to put 20 zeros, for example. All right, there might be only 8 or 9 places or 7 places on a calculator. And so then they have to show that number, if it's a power of 10, show that number in scientific notation. Okay? It's also used in sciences, especially in like biology or physics that have really, really small numbers that they have to write. And honestly, when you learn to read scientific notation, it's easier to read than having a number with 20 zeros in it and then trying to figure out what is that number. Okay? So, how do you write scientific notation? Well, the first thing about scientific notation is that the first number, this number, first of all, is in scientific notation when it says 8.6 times 10 to the 6th power. This is how you write a number in scientific notation. It'll always have a times 10 and then an exponent. So, 8,600,000 can be converted to scientific notation if you take the first set of digits, the first non-zero digits, or all the way up to where the zeros start, and write that number with a decimal point after the first number. Okay? If you put a decimal point after the first digit, then that first number will be a number that's between 1 and 10. Whether it's 8.6 or 4.2 or 5.92, these are all numbers between 1 and 10. So that's the first step when writing scientific notation, is to find the first set of digits that are non-zero digits up to where the zeros start, and put a decimal point after the first non-zero digit. Okay? Does that make sense?
Yeah, it does.
You just put the decimal point after the first non-zero digit. Okay? Then, after that, you count the number of places to that digit. So, here's the first digit. How many places are there after that first digit? 6 places. That number 6 tells you what the exponent will be, or what power of 10 you will write. So we write 8.6 because that's between 1 and 10. And then you write times 10. And then figure out the exponent by counting the number of digits behind the 8, or behind where you place the decimal point. Okay? Now, let's look at one with that's smaller than 1. So this is 42 thousandths. 42 thousandths. Now, this one, a number that's less than 1 always has a decimal point already in it. And so what we'll have to do, what you do is you move that decimal point to behind the first non-zero digit again. So that you have your first number in scientific notation is between 1 and 10. 4.2, the value of 4.2 is between 1 and 10, isn't it? Okay? It's not less than 1, it's not 0.42, that wouldn't be in between 1 and 10, and it's not 42, because 42 is higher than 10. The first number in scientific notation has to be written between 1 and 10. Okay? Now, we have to count the places that we moved the decimal point. How many places did we move the decimal point, Jeff? 2 places, right? From where it was written originally to behind the 4, there's 2 places. Okay? Now, since you had to move the decimal place to the right and change the number that way, that's a negative exponent. It's a negative exponent. In other words, we're starting with a really small number, 42 thousandths, and writing it as 4.2 times 10, but that power of 10 is not 1,000, it's 1,000th. It's a negative exponent. If you wrote this as a positive exponent, that would mean that this 4.2 would have to multiply by 1,000. And that's like 4,200. In fact, it is 4,200. It's not like 4,200. Right? So in order to make these two equal, you have to use a negative exponent. If you're starting with a really small number, just think you wouldn't multiply that by a big number to get back to the original number. You'd have to multiply it by a small power of 10, or a negative power of 10. Is this making sense? Thumbs up if this is making sense.
Yeah.
Okay, good. Now, what if you had to multiply powers of 10? This is one that they test your knowledge of multiplying powers. And have you multiplied 2 numbers that are written in scientific notation? Or 2 numbers that are multiplied by powers of 10. So, because of what we learned about multiplying numbers with the same base, these are both base 10. And so what can you do with the exponents? Olivia? You just add the exponents. This is 10 to the 6 plus 4. So you end up with 10 to the 10th. See, here's the 6, here's the 4. So this is 10 to the 6 plus 4. What's 10 to the 6 plus 4, Matt? To the 6 plus 4. Were you listening?
I don't know.
What's 6 plus 4?
600.
Oh no, what's 10 to the 6 plus 4? I drew an arrow right to the answer to see if you were listening. It's 10 to the 10th power. Yep. Now, what about these other 2 numbers? 1.6 and 3.7. Do you add these 2 to multiply? 1.6 and 3.7 multiplied together? You don't add the first numbers, you times them. Yep. Because of the commutative property, you can multiply the numbers in different order, can't you? So we don't have to multiply these numbers first and then multiply these numbers first. Since everything is being multiplied, you could multiply these 2 first and then multiply these 2. Okay? None of these numbers are being added to each other, so the order of operation says you can multiply all in the same step, and you can multiply in a different order. So you can multiply 1.6 times 3.7 and get that answer. What is that answer? Tate? I pointed right at it. Yeah, 5.92. And then multiply 10 to the 6th times 10 to the 4th, and what is that? Pete? Isn't anyone listening, you guys? None of you are listening. Every person I call on, I mean, pointing at the answers and you don't have them. Okay? Listen. 10 to the 6th times 10 to the 4th. 10 to the 10th. So you multiply the numbers and then multiply the powers of 10 and write the answer. Okay? Now, what if you do this and let's see, what if you end up with a number like this? So you multiply the two numbers and you end up with 483 times 10 to the 8th power. Is this number in scientific notation? No, it's not, is it? Why not? Why isn't 483 times 10 to the 8th power, why isn't that in scientific notation? It has to do with this first number. Allison? What do you think? What's starred in your notes about the first thing about scientific notation? Yeah, the first number has to be between 1 and 10. So 483, is that between 1 and 10? No. 483, is that a number between 1 and 10? No. Where would we have to put the decimal point in order to make it between 1 and 10? After the
4 and before the 8.
Yeah, we'd have to put it after the first digit. Which would have to mean we'd have to move it 2 places from 483 to 4.83. But now it can't be 4.83 times 10 to the 8th power because we've just moved the decimal place. We're going to have to multiply it by a different power of 10. Then it?
Power 6?
Would it have to be a smaller power of 10 or a bigger power of 10?
Power 6 is small.
A smaller power of 10? If we move the decimal place to the
bigger,
right, we make
sorry.
it smaller. So, fix your answer.
Bigger.
It would have to be bigger. We'd have to, since this is 2 places, we'd have to add 2 to our power of 10. Okay? What would the answer be then? Not 10 to the 8th power. Nate?
10 to the 10th.
10 to the 10th power. Yep. 10 to the 10th power. Okay? That's the same as 483 times 10 to the 8th power. So to convert this to scientific notation, you have to make sure the first number is between 1 and 10. And then, if you have to move the decimal place to the left, you add to the power of 10. If you're moving the decimal place to the right, then you would have to subtract. Instead of adding, you'd subtract from the power of 10. Okay? So, let's look at the bottom numbers. Okay? So, let's say that we start with 0. Well, let's do the first one together from your worksheet. Let's see. What would we do with 3.7? 3.77 times 10 to the 4th power. How would we convert that to standard form? We're starting with scientific notation, how would we convert that to standard form?
You have to like make it into the numbers. You have to have 4 digits after the point.
Yes, you'd have to move this decimal place 4 places, right? So 3.77 converts to what? Megan? Look at what I added here. 3. You moved it 4 places because of the exponent. So it's 37700. Now put a comma in.
37,700.
Good, 37,700. Number 1. Number 2. Number 2. Trevor. What are we starting with?
8.5 times 10 to the 3rd power.
Yep. Then we'd have to move the decimal place over 3 times. 8.5. 1, 2, 3. What would we put in the open spaces? Zeros. Now write the answer. What's the answer, Trevor? Very good. 8,500. Okay. Skip to number 5. Pluto is about 3,653,000,000 miles from the sun. How would we write that in scientific notation? 3,653,000,000. And we're converting that to scientific notation. What do you think, Abby? What do we have to make the first number?
3.653.
Good. 3.653. Which means that we have to count all the places up to after the first digit. How many is that? That's 9. So it's 10 to the 9th power, because this is 9 places. Okay? So it's 3.653 times 10 to the 9th power. Okay? Your assignment is to finish the worksheet, 1 through 21. Okay?